Monika, Department of Chemistry. Today I am going to take about on the topics of primary battery, that is an alkaline batteries. So we have already discussed about this primary battery. What is the primary batteries? The batteries which can carry out the only one source of energy and it cannot be rechargeable battery, that is the primary battery. In that we have that examples of the dry cell or mercury cell. For that I have taken the examples of an alkaline batteries as a primary batteries. The alkaline battery is nothing but which is in the improved form of this dry cell batteries. The dry cell battery is nothing but both the reactions. When this is the structure for this primary batteries, we have already seen this is filled with the carbon rod which is filled in the center of the tube, and the overall the electrolytes is mixed with this solutions of mixture of MnO2 and KOH, zinc, starch and the water in the form of a paste using this starch and the water, and the outside zinc body which is act as an anode, and the top the metal cap which is act as an the positive, and the sliding of this insulating washer which is used for this alkaline batteries. So the working of this battery is the total body of the zinc body which act as in the same upper of the tube, that is the zinc body, and from this two side positive and the negative side which is connected to the batteries, and this balance the remaining portion which is filled with this electrolyte solution, that is mixed with this manganese oxide and mixture of manganese oxide, potassium hydroxide in the form of a paste using this starch and the water, and it is filled with this center, and the center film which is filled by this graphite rod, that is a carbon rod which act as a positive and the negative. So this is the working about this alkaline batteries, and how the reaction follows and produces the current can be seen by using this. The anode reaction which is followed by this zinc. So ZnS plus in the form of mixture of an hydroxide, that is starch and the water, can be calculated by using 2OH aqueous medium, and with this reaction follows by ZnOH2, that is zinc oxides. Okay, so oxide with 2E minus, the liberation of the electrons with the loss of electrons. And in the cathode reactions we are taking as a mixture of MnO2 KOH as a 2MnO2 plus in the form of water H2O. With this gain of electron, cathode will gain the electrons and it reverses the reaction as Mn2 is a common 2Mn and O2, so we can calculate it as 2 as 4, 2MnO2 MnO4. So we can take it as Mn2 and O4. From this O4 we are calculating only O3. Balance one O is converted into this water molecules and it has already H2. So one O is transferring to this water molecules and it taken as a common of 2 OH minus. So the reaction follows as 2MnO2 plus H2O with the gain of 2E electrons, and the reaction follows as MnO2O3 plus 2OH. And with this anode and the cathode reaction we are considering this overall reaction for this. So we can take it as zinc plus 2MnO2 and H2O. So 2OH2 with the same reactions can be cancelled. So cancelling, and the overall reaction gives ZnOH2 plus Mn2O3, and 2E minus can be cancelled. So the overall reactions for this is zinc plus 2MnO2 plus H2O, and the reaction follows with ZnOH2 plus Mn2O3. So this is the process under how the batteries can be running by using this alkaline batteries. And from this the manganese oxide, the M is converted is plus from the +4 oxidation state to this +3 oxidation state, and it gives the EMF of the voltage produces as a 1.5 voltage which we are using in this watch and calculators as we have already seen. And in the remote we are using this cell of battery, that is dry cell battery. It is also from the same functions and it produces a voltage of 1.5 voltage. And the advantages of this battery is we can use by using this starch and the water, it can be converted, and the battery is used in this calculator and watches. Thank you.